Hi, in this video we're going to talk about how to use our graphing calculator to find the p-value when we're doing hypothesis testing for two means. So this goes with section 9.3 in our notes. We're actually going to go through two examples, one where we use the data feature where we can directly put in data, and one where we use the stats feature where we already have the mean and the standard deviation. Okay, so we'll start with this first example. So the claim is that women's pulse rates are higher than men's. Okay, so we have two different populations. We'll call our first population the women and the second population the men. And here we'll need to be really careful of keeping track of which one we're putting women in and which one we're putting men in. Okay, so our null and our alternate hypothesis, since we're calling women population 1 and men population 2, our null hypothesis would be that their means are equal. But our claim is that women's pulse rates are higher than men. So our alternate hypothesis would be mu1 is greater than mu2. And we're going to use a 1% significance level here. Okay, so here we've got the study results. So we've got 10 random men had their pulse rates checked and 12 random women. It doesn't matter that they're different amounts. Okay, we're going to put the men in L1 and the women in L2. Now we have to remember this is a little backwards. You know, this is how they're listed, but remember we're calling women population 1. So we'll see how we handle that in a minute. But so remember to put them in L1 and L2, we go stat, edit, and we want, and they're actually already in here, but so the men are in L1, okay, and the women are in L2, and I'll scroll down just to show you there are 12 in there. Okay, so those are already in there for us. Okay, now to do this on our calculator, now we need to remember that the women, which are in L2, is our population 1. Okay, so we're going to go stat, we're going to go over to tests, and we're going to choose number 4, the 2-sample t-test. Okay, now we're going to use the data here, so we're going to switch it over to data. Now, list 1 needs to go with population 1, and remember our list 1 was our men, or our L1 was our men. We want our population 1 to be our women. So we're going to hit second stat to go to the list, and we're going to choose L2. Okay, and then list 2, we want that to be for population 2. That was men, and we put those in L1. Okay, now frequency for 1 and 2, you're just going to leave those both 1. And then here, our original statement was that mu1 was greater than mu2, so this is already on this one. We're always going to leave the pooled on no, and then we're going to hit calculate. Okay, so here we get our t-value, which we don't need to make any decisions, but we also get our p-value. Okay, and remember our alpha was 0.01, so since p is much bigger than 0.01, we have not rejected the null hypothesis. Now, since our original claim was the alternate hypothesis, we do not support the claim that women's pulse rates are higher than men, significantly higher. Okay, so now we're going to do a second example where we're going to use the stat feature instead of the data feature. So this example says that a company conducted a contest for promotion. Some of the employees who were not promoted filed a lawsuit claiming that the competition involved discrimination based on age. So the claim we're testing is that employees who were not promoted were significantly older than those who were. Okay, so we have two populations again, the employees who were not promoted and the employees who were promoted. So we'll call the ones who weren't promoted population 1 and those who were population 2. So our null hypothesis is always mu1 equals mu2, and here we're claiming the ones who weren't promoted, mu1, are older, so greater than mu2. And here we're going to use a significance level of 5%, so 0.05 for alpha. Okay, so here we have just some statistics instead of the actual data. So we're going to go to stat, tests, and choose number 4 again, and we're going to pick stats instead of data. So now we've got the information for the not promoted employees that were our population 1, so we're going to put those in x1 would be our 47, our mean, x bar 1. Our standard deviation is 7.2, and our sample size is 23. And for our second population, our mean is 42.5. Our standard deviation is 5.9. and our sample size is 30. Okay, and remember we were claiming that the ones who weren't promoted, mu1 is greater than mu2, so we'll leave it there. Okay, and we'll hit calculate. Okay, and here we see that we get our p-value of 0.0096. So since this is less than 0.05, our alpha value, we reject the null hypothesis. Since we reject the null hypothesis, we support the alternate hypothesis. So we support the claim that employees who were not promoted were significantly older than those who were promoted. So just a reminder, to do two proportion stats with the mean, you're going to go stat tests and two sample t-tests. This is a t-test because we don't know the standard deviation of the entire population.